The OSI model, Open Systems Interconnect, is what it stands for. There's 7 layers: application, presentation, session, transport, data, network, and physical. So that's the 7. So the layers are service protocols in layer 7, service protocols in layer 7 at the application level. Presentations, more like data formats. Session is authentication and cryptography. Session layer is authentication and cryptography. That should be red. You'll see a test question about that. Transport, layer 4, you will see this as a test question. Ports, logical service to service, and TCP. You'll also see a test question about data on layer 3, network to network, which is where PPTP comes in, point-to-point tunneling protocol, and things like CHAP, challenge handshake authentication protocol. Network, host-to-host links, and physical is the media, coax, TCP/IP, radio, satellite, whatever the medium, microwave. So now we're going to discuss CIA, confidentiality, integrity, and availability. Okay, what does that mean? You're going to see a lot of test questions about this. They'll be commingled and specific, pointed questions about it. So you need to understand these in good depth. Confidentiality, integrity, availability makes up the CIA triad. Another thing about this, the CIA, when you Google this, is going to pull up all the Central Intelligence Agencies. So you'll also see it as IAC, I believe. They took the C and just moved it to the end. So it's integrity, availability, confidentiality, IAC. I believe that was the change, something kind of recent. So when you Google it, you can find the context-sensitive information. People are so lazy, everything's a Google answer nowadays. But anyway, this is a real problem. So when you're talking to people about it, you might want to use a different acronym, IAC. But it's confidentiality, integrity, and availability. The confidentiality comes in keeping data from being exposed to those that should not have access to it. That's the formal definition. Integrity, I mean, confidentiality, that makes sense, right? You keep data from being exposed to those that should not have access to it. You keep it confidential, only letting people see it that should have access to see it. Think role-based access control there. Integrity, keeping the data from being modified, tampered with, or deleted by those whom should not have access to it. So integrity, you're keeping it correct. You don't want me changing passwords in a database. You don't want me destroying passwords in a database. Availability, keeping it available when people need it. Uptime, think uptime. Also involved with this is an SLA, which is also called a service level agreement. That's the actual definition of the acronym there. So availability, integrity, confidentiality, very important. We'll see a lot of test questions surrounding these topics. When you go to conduct a network security assessment or penetration test, you must have the proper permission. This can get you in so much trouble if anything happens. A lot of times, like we've previously discussed, a hacker may come along, or a bot or an automated system, and start tinkering with the network while you're on it. You don't want to be responsible for any kind of problems. So make sure you get permission, and then it needs to be your get out of jail free card so that there's no issues on your end. So you want to let the customer know that things can happen while you're in there. The trick is to develop trust with the customer so that they trust you, and the trust comes into play not that you're going to rob them, but that you know what you're doing and you're not going to bring down their production networks while you're conducting these tests and assessments. Another part of this problem is that, say you're using a Nessus scanner that'll work in parallel, and you're not going to totally dominate their network so that no other customers can reach them, effectively causing a denial of service. That's the biggest tragedy you could probably cause. So you need to be very careful about that kind of thing. But at the same time, you need to CYA in this business. We're going to talk about that more later when we talk about obfuscating your IP address and things of this nature. So you need to make sure that you have permissions and a blanket get out of jail free card. So it shouldn't be that difficult. It's very common for people to get, so the customer shouldn't push back too much. If they are, you need to investigate why that is. Maybe bring in a lawyer or something like that if you need to. So you want to sign a formal contract and a non-disclosure. You're not going to disclose any of their information, and you need to make sure you do that. How do you do that? By encrypting the data. So this last slide, store and or destroy the data. If you're going to destroy the data, on the last bullet on this slide, if you're going to destroy the data, make sure you use a 32-bit, 32-pass delete and overwrite, something like Derek's boot and nuke for a system. If you're using a system to store the data on, you want to run DBAN. It's called DBAN, Derek's boot and nuke. It's been around for years and is still very effective. You want to use a 32-pass delete. You may see a question about that too. That's a government standard, 32-pass delete. Takes a long time to do, especially if it's a lot of data. It's very effective in destroying the data permanently. Information gathering, which hosts are in play and which ones are not, purpose of the test, etc. When you engage a customer, you want to know, why are you conducting this test? Is it just for you? Is it for compliance? Is it for your customer? Because you as the consultant have to write the report accordingly, and whatever they need, you need to make sure you satisfy, otherwise you're going to have an angry customer on your hands. So make sure that you understand what the scope of the test is, why you're conducting it, and what their bounds are going to be. What kind of a report do you need to deliver? If it's going to be a deliverable report for a compliance, say PCI, SOX, Sarbanes-Oxley, or GLBA, or Graham-Leach-Bliley, they may have one particular customer that's demanding this test, and that's the only reason they need it. They may not care so much about the security, but you need to let them know what the holes are so they can give it to the customer, and the customer can therefore kind of dictate what they're going to fix and what they aren't, you know, things of that nature. So make sure you understand that and test accordingly. You're going to permission to perform the assessment. You're going to be given a window. Make sure you stay inside of your window. Say you start the test. This happens so often. You start the test, and then for some reason you're not able to continue the test. You find a serious problem, or the app that you're testing doesn't work for some reason, so they've got to go back and fix it. Your window expires. You've only done the first hour of work, so you have a lot more hours of billable time that you can bill them for, but your window of engagement's closed, so you can no longer touch that network legally with your get-out-of-jail-free card. So what'll happen is they'll come back to you, hey, we got the app fixed, go ahead, test our infrastructure now with this app. No, you need another permission. Don't mess around with that. Make sure you get the permission updated for the next 2-week window that you need. A lot of times, customers may not care so much. You might be able to get a 6-week or 2-month window, something like that, if they're expecting problems. So just talk to them about it. My suggestion is keep the window as small as possible. You have less exposure. If you need more time, just add an addendum. Say, hey, I need to extend our window for another 2 weeks. Is that okay? Or another week or 3 days, whatever it is you need, and let them know accordingly. Their network engineers need to plan. The SOC needs to plan. If you're attacking something and they're able to detect it, and you're not in your window, the SOC may not have been notified, and they'll just start blocking your IP address, and you won't be able to test anymore. Or they may report you if you're using an Amazon Web Service as your source machine for scanning. They may block your host permanently. So it's a lot of problems on your end. Then you have to justify why you did it and all this kind of stuff. Even though it's legal, it's still a pain for you. So it's best to avoid it altogether. Participate in remediation requests. Are you going to need to? You need to find out up front. If you are, that's separate billable time. Make that clear in your contracts. You want to turn over your deliverables. Whatever you say you're going to deliver, make sure you deliver. You have to check that box. When it comes time for data, you need to ask them up front, do you want the data? Do you want me to put it on an encrypted portable drive so that I can give it to you and then it's out of my hands? Let them destroy it. It takes a long time to destroy the data, so make sure you build that into your time. If you're going to keep the data, make sure you be responsible and encrypt it accordingly, and don't let it out of your hands. If you have unencrypted data and it's stolen, you need to inform the customer. Virtual machines. There's VirtualBox. And then there's actually many virtual machine platforms out there. VMware and VirtualBox are probably two of the most common. VMware is not too expensive, $235 for Windows. A VMware Fusion for OS X, I think it's about $135, or it might be $230. I think it's $135 for the Pro version, something like that. It's not too bad, and they work very well. Certain OSs, when they're new, will have some issues, and then the VMware or VirtualBox, they'll go in and fix the problems pretty quickly, but don't try to use the most cutting-edge version of VMware or VirtualBox with the newest release of the OS. It can cause some problems. I've had a lot of problems with that, like consistently, so there's some issues there. The VMware can run just about any OS. There's a few tricks to getting OS X to run in VMware Fusion and VMware, and also in VirtualBox. So just Google the instructions. There's plenty of them out there that tell you step by step how to get it to work. It's not too difficult. You want to use VM virtual machines for detonating malware, looking at rogue emails that customers send you, all this kind of thing. Don't try to do it on your native machine. It's a very bad idea. Plus, it's part of the CYA process. Even though you've got permission to touch their network, in the event that something happened, like an attacker attacked their network while you're on it, if the customer decides to come after you or wants, for whatever reason, wants to point the blame at you, they're going to have a team of lawyers. Usually you're just one penetration testing guy. It's best that you make them prove the case, right? So if you're CYAing and you're using something like private internet access, which we'll cover later, to hide your IP address, they have no real proof that you did it. So you can provide the screenshots and things like that. Just be careful what you say. It's very good to CYA. Just don't take a chance. So the virtual machines come into play there because you do everything from the virtual machine. If you're using private internet access, it'll look like your IP address is overseas. So also you want to test with overseas IP addresses. There's all kinds of reasons, and we'll get into some of those later. But anyway, virtual machines are very critical, highly recommended. So if you don't have any experience with these, this will be part of the lab. Make sure you spend some time playing around with these things.